Hey there, so this is intended to kind of review what we've done in class. So there are 4 properties that we're going to talk about during this video, and they're going to be indicated by title headers and different colors. So when the color changes, we're really talking about a new problem. So this is called a difference of squares, and why it's called that is because difference is for subtraction, and squares means you're taking one square thing and subtracting another square thing. So where we think about a and b could be any monomial, any term, any set of terms. So like a could be 2x. Then we can factor this polynomial since we know that a plus b times a minus b is equivalent to that. So if I were to distribute this, I would simplify to this, and it's kind of a fun exercise to go ahead and do that. But for now, we're really using this structure to identify, okay, it looks like I have square numbers. This is really helpful if you have like 1 squared, 2 squared, 3 squared, 4 squared, and you have them on your paper, and you have access to them. So like 1, 4, 9, 16, and you have access to those. Keep going all the way to 12, and that'll give you a good idea of perfect squares. So I see that there's something squared here, and there's something squared here. Well, if I look at my list, I notice that 4 squared is 16. So 4 squared is the same as 16. So in that box, we can put 4. And something else squared is 81x squared. Well, I know that 9 squared is 81, so 9, and then x squared is x squared. Okay, so here we've got our a value, and in blue we've got our b value. And the way that most of this entire video is going to go is once you figure out an a value in red or b value in blue, you're going to just plug them in. So into this equation, we're going to substitute a for 9x, so 9x for a, 9x for a, parentheses, 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 plus, minus, and then whatever the b value is. So b is 4. So you can factor this. So this can be factored into 9x plus 4 times 9x minus 4 by identifying the a and the b. Again, you can do that here. Something squared is x to the 4th. Minus something squared is is 16. We know that's 4 because we just did a problem about it. But we have to remember our exponent rules. X squared, power to a power, multiplies. And so my solution is a plus b, a minus b. So a is x squared, a plus b, and a minus b, and b is 4. So it's pretty easy to factor if you see something is a difference of squares. There's something else called a square of sums, right? So what that means, a square of sums, is we're taking stuff to the power of 2. You're squaring a sum of 2 items. And what I can do is, this is the proof of this, is that I can say, oh, a plus b squared is the same as a plus b times a plus b, and if I factored it, if I distributed, I'd get this. And so it's really handy to kind of have this on the side, because once you know what your a value is, then you can just plug a in, and once you know your b value, you can just plug b in. And so here, if we're looking at this particular problem, we've got an a value, and we've got a b value. And all we need to do to distribute this, or to simplify this, or to expand this, right, is to use this formula. So what we're going to do is a is, I'll label those, a is 3x and b is 4. So a squared is 3x squared plus 2 times a times b. So a is 3x, and b is 4. So we're just substituting things in. Plus b squared. We're going to substitute whatever b is. So b is 4, and you plug it in. Now, all you got to do is simplify. So 3x times 3x is 9x squared. 2 times 3x times 4 is 24x. And 4 squared is 16. So this is the expanded version of this square of sums. We'll get you one more practice on this. So try using this identity, and actually we're going to skip this last one. We're going to not do this in this video. you could, I guess it's a good thought experiment. But try and use this identity, and please pause the video because I'm going to do it while you're working, and then it'll magically appear. Actually, I'll give you a hint before you go. Think about what's A and what's B. So we think about A is 2x and B is y, so use those appropriately. All right, hopefully you got this as well. I think the tricky part is this middle piece where you're multiplying 2 times 2x times y, right? It's not distribution, we're actually multiplying these together. All right, so this is the third of the 4 things. It's called a difference of cubes. Before you do that, please pause the video really quickly to multiply these, and hopefully if you do, you'll notice something kind of cool. I'm going to please pause the video because I'm going to do it magically so this video doesn't take forever. So if you get to this point, when we look at the diagonals, they end up canceling out, right? So 12x and negative 12x are 0, and 18x and negative 18x are also 0. And so we're left with 8x squared minus 27. Excuse me, that should be x cubed, shouldn't it? 8x cubed minus 27. Now, if you notice, we could do think about it, the difference of squares was we're taking squares and we're subtracting them. So the difference comes from the subtraction part, and hopefully we can do something like this, that there are cubes in there. So if you look at your list of cubes, hopefully somewhere on your paper you have 1 cubed and 2 cubed and 3 cubed and 4 cubed, just so that you can start to notice, so 1, 8, 27, 4 to 64, so, and keep going until probably be about 8 is about all you need. But notice that 27 is 3 cubed, so what goes in there? It's gotta be 3 cubed. And 8x cubed, well 8 is 2 cubed, so 2x cubed. So now, I hope that you start to see this kind of coming together. 2x is there, and 3 is there. Your a is going to be 2x, a is 2x, b is 3. Maybe think about how those numbers come to be 3 squared, 2x squared. So there's lots of patterns and relationships here. So we're actually going to do this problem going forward. And I want you to think, okay, if we know that this is a difference of squares, go ahead and write down this formula. And this formula is a little bit magical about how it came to be. But at this moment, you really need to just learn how to apply what it's saying. So go ahead and write that down. And then we're going to think about this example problem. And your example would probably say, factor the polynomial. And you see, oh, I know my factors of cubes. I know my cubes. And so go in here, something cubed minus something else cubed. Well, that's easy. X cubed is x cubed. And 2 cubed is 8, right? 2 times 2 times 2 is 8. So what I can do is now I can use this equation, this relationship, because I have A and I've got B. So my A is the first thing, and my B is the second thing. So it's going to be A minus B. So, and if I'm using my formula, it's A take away B. So A is, I'll do it in blue, X take away 2 times, and then we're going to put it all in big parentheses. And then we'll do A squared. So A is X squared plus A times B. Well, A is X, and B is 2, plus B squared. B squared. So B is 2. And now we got to simplify. So X minus 2 stays X minus 2. X squared is X squared. X times 2 is 2x, and 2 squared is 4. So eventually you're going to be asked to simplify this even more by factoring the second term, but that's not the purpose of today, but just know that you can still factor this by factoring that second part as well, and that's coming along. So don't do that yet. Maybe if you want a quick thought experiment, it might not be a bad idea to try, but just so you know, it's coming. So go ahead and give this a try. I'm going to please pause the video to try and use this use the difference of cubes formula, the identity, to factor this polynomial, this 64x cubed minus 8. So pause the video now. So just quickly double check that your setup is good here, and that A is 4x and B is 2. And check this final answer here in factored form. So you factor this polynomial down to 4x minus 2 times 16x squared minus 8x plus 4. Kind of procedural, yeah? Hopefully you have these written down. And then there's one more. There's one more that we're going to do. So this is the sum of cubes, and it's really kind of the same thing, but it's just a different formula. So instead of having a plus in there, it's going to be a minus. So there's minor differences in the formula, and I would honestly just have a formula sheet. So I think you can do this without me going through it, but I'll start setting it up, and then magically the answer will appear at the end. So pause and continue as you need. All right, here's a slightly more challenging problem. The key here is to identify what is the A and what is the B. So pause real quick if you need to. Your A value has got to be 2x, because 2x times 2x times 2x, well, 2 times 2 is 2, times 2 is 4, is 8, excuse me, and x times x times x is x cubed. So yes, that checks out, that works, and then your B is going to be y. All right, so here's my summary slide of the 4 things. I would take a picture of this or write this down for your use. I personally would use this a ton on my tests and quizzes so that I had access to it. And the next thing that I'm going to show you just really quickly is practice opportunity, or an opportunity to identify, when do I have a difference of squares? When is it a sum of cubes? When is it a square of sums? When is it a difference? So if I see a problem, which method am I going to choose? Which tool am I going to use? So please do use this Desmos card sort, and you can kind of choose whichever you'd like. You're not going to get any feedback because it's not live in class, but it is a kind of a nice tool to be able to kind of think through what goes with what. What is a difference of squares? Which of these problems is a difference of squares? That's kind of nice. So thanks for watching the video. I hope this was helpful.